Have you ever stopped to think that virtually everything we use in our daily lives is based on technology? Even further, do you understand the software behind this technology? Welcome to The Art of Software with Martin Lacey. In today's program, you'll hear how software is created and implemented, why it's written the way it is, and learn from its success stories, proven best practices, and significant failures. Now, here is your host, Martin Lacey.
Good morning and welcome to The Art of Software. I am Martin Lacey, your host from Lacey Software Technology Corporation. And today we're speaking with Piers Hollett from Sierra Systems. Paul Twigg, unfortunately, had a conflict and was able to provide some of his notes to Piers. So we'll just be speaking with Piers today. Let me just give you a brief intro for Piers. Piers Hollett is a technology principal with Sierra Systems. He's worked in the software industry for 20 years, specializing in the health IT solutions, XML technologies, and enterprise mobility. As an architect like myself, Piers has led development of several enterprise exercises specifically for him in the healthcare registries and information exchanges, and is involved in the standards and profile development communities. So that means he's keenly interested in the way things are built and making sure that they're built well, as a good architect should. Welcome to the show, Piers.
Hey, thanks. Can I say a few things about myself before we get going?
Oh, absolutely. Please do.
That was a great introduction.
I'd love to hear more about yourself. Please explain.
Yeah, so specifically, I'm a solution architect for the BC Provincial Lab System here in British Columbia. It was built by Quest Diagnostics and Sierra Systems for the Ministry of Health. It's been around for about 10 years, and we reached our full onboarding about 4 years back, when we brought in feeds from all the community labs. So that was a huge milestone and a huge undertaking, and something to be proud of. Right now, we're in more of a maintenance mode. We've moved out of active development, so we have a smaller team, but we still use daily meetings to stay in touch and weekly status checks. And we're doing AMS development. We work closely with the AMS operations people and a variety of other stakeholders. So one thing that I find really interesting about working on this program, particularly in healthcare, is the number of stakeholder organizations that are involved, and the way basically success and failure comes down to your ability to work together. So I think that's a very important point, and one of the things I'm sure we'll talk about today. And also, although I'm a Java architect, I work with Java Spring. From a development point of view, I also love UX design and building with JavaScript and other client-side technologies. So it's kind of ironic that I spend my work life talking about an enterprise healthcare system that's entirely message-based, doesn't even have any UI.
Yeah, and that's interesting. I mean, I've done a limited amount of interfacing with the healthcare systems. One organization I dealt with was a online pharmacy, so of course all of their scripts had to be cleared by doctors, and we had interfaces to the underlying healthcare system. So I guess that's part of what you're trying to revolutionize is that interface to the healthcare underlying healthcare systems, and how pharmacies and doctors' offices and other practitioners interact. Is that correct?
Right. Absolutely. I think that one of the things that we deal with a lot in healthcare is putting all our eggs in one basket, centralizing things, and then building data warehouses, moving data around in a contained and secure fashion so that we can get a better understanding of what the entire enterprise and industry is doing. And it's very important work.
Well, absolutely. And the risks or the downside, if it's not done right, are spectacular, in that you're dealing with very sensitive information. You're dealing with personal data. So it has a big impact if there's any kind of issues anywhere down the line of any layer of the software.
Exactly. You know, I joke that my job as a software architect is primarily to be simultaneously completely paranoid and stay totally calm. But that
Yeah.
about sums it up, whether you're working on healthcare or you're working on a justice project, you're working in government, or if you're working in the private sector on a consumer application, if you're working at a nuclear power plant and the software there, the stakes are always going to be high because the reality is you're working with customers' personal information. That always introduces risk. To put it bluntly, a lack of understanding of the risks which are involved, that's the main reason why significant failures in software happen. The
Totally
risks
agree.
can be categorized into three main categories, I think. First, we talked about data. There are risks around data, the type of data, where it's stored, how it's collected, how it's stored, how it's transferred. All those things introduce risk. Our business is information technology, and that means data. That's a reality.
Yeah, and that's critical in terms of managing that data, making sure it's secure, and as it passes through all the various layers and functionality that your application presents. There's the sensitivity of the information that you're transmitting, and then we've got other applications which are sensitive based on the timeliness and the effect it has. For example, in a real time plant situation. So when you're dealing with information that's being managed and running the plant floor and making decisions as to quality assessment and where things should be changed, that type of information is just as critical because it impacts the direction and the management and the running of the company. It is not so much sensitive in terms of it's not exposing sensitive data other than raw processing data. So there's different wrinkles depending on your software, but the need is still there. It has to be absolutely secure and protected.
Right, and I mean the irony is that even if you may be dealing with interactions between different systems which take 2 seconds, 2 minutes, doesn't really matter, maybe milliseconds, but what you're also dealing with is requirements gathering, and that can take months or even years. So that's really important. The requirements and applications are often perceived to be absolutely essential, but are they? Really, who gets to make the determination about what the requirements are? Maybe it's the... Go ahead.
That's a really good point because requirements, I mean, if you let them stew long enough, they change.
They change a lot over a decade, and a typical healthcare project, for instance, takes easily a decade to develop, get into maintenance, and then continue on into sustainment. And that typically, as you're doing that development, you get further and further away from the end users, your clients, your customers who are actually using the system, because you do requirements gathering. You think that captures your business perfectly, and then you step away. Your end user, well, all they want to do is automate their world, but in isolation, that's fraught with errors. I mean, look at the Phoenix payroll system, which is hitting a lot of headlines right now, which IBM developed for the Canadian government. Was it the tools or the processes that caused that system to go where it did? At $150 million, it's an expensive failure, but the software that's too complex just becomes impossible to manage and maintain. And that's where failure comes from, is just complexity and size. It's hard to manage.
Yeah, and that complexity is really the bugbear in software. It's the approach of breaking it down into smaller pieces so that you don't have those complex issues. Something that's smaller, more tangible, easier to wrap your head around, and of course wrap test routines around and automate that process. These are all bits and pieces, at the minutiae, at the very fine level that we as our software visionaries, software architects need to make sure is in place. And, we need to make sure that that's understood by the business, how important it is.
Yeah, right. I mean, you're dealing with requirements, use cases, tests, but more importantly, you're also dealing with people, and we need to not become complacent or take a piece of software for granted. For example, you export data, you put it on your executive's laptop, his phone, you walk away, and it gets lost in an airport. That kind of failure happens all the time, and it shouldn't, but it happens because of complacency, and it happens because of lack of understanding of the risks which are involved. Is that a software failure or a process failure? Well, it's both. Software it's smart enough to understand data. It shouldn't be stored outside of certain boundaries, but those boundaries are also very permeable, and that introduces huge risk. And we spend an awful amount of time mitigating that risk.
That's an excellent point, and I think we want to jump right back into that, managing risk, managing the scope, and defining those issues. As soon as we come back from our break, we're going to have a short break now. Thanks, Piers. We'll be back shortly with the Art of Software and Piers Holland as we discuss and review how to better run and implement projects so that failures don't occur.
Awesome.
Great. Thanks, Piers.